Slight correction, the gallons should actually be 15 at 186 miles, and after 320 miles, the gallons should be 1. So we actually decreased by 14 gallons, and we do that over the course of this difference is, well, we've driven 134 more miles, and the ratio of our output to input is actually, a lot of people would want to do 134 divided by negative 14, but this is our output value. Relates to our output value. So negative 14 gallons consumed across 134 miles. Well, that means if you divide the two, negative 14 divided by 134, well, that tells us the gallons per mile, and we'll round to the tenths place since we don't probably need to be too exact here. So we get negative 0.1 gallons consumed per 1 mile. So you consume a tenth of a gallon for every 1 mile that you drive in this truck. So how does that help us in writing our formula? Well, our formula needs to be determined by an initial value. So we want to be able to predict the gallons of gas based on, well, first of all, we need to know where we start when our distance is 0. So what is this point right here? That's what we're trying to figure out. That's our big question mark. And we know that we now know it's going to decrease by 0.1 gallons for every, or times the number of miles driven. So we need to figure out this value here. The question is, how do we do that? So the beauty of that ratio is, and here's just the whole thing redrawn again, is that if I lose 1.1 gallons for every 1 mile that I drive, this is a proportional figure. So remember that means that if I drive 2 miles, well, I'm going to lose double the number of gallons, or negative 0.2 gallons. So the fact that if I double this, I have to double this, tells me that this is a multiplicative idea. So if I drive 186 miles, that's 186 times what I get for 1 mile, so I have to multiply negative 0.1 by 186 too to figure out how many multiples of 0.1 I'm going to lose. So that means I'm going to lose 18.6 gallons if I drive 186 miles. Now think about this like going back in time. So now if I could kind of rewind, and I want to come back here and figure out how many gallons did I have after initially driving 0 miles. Well, I have to undo 186 miles to get back to 0. So I have to subtract 186 to go this way. But if I go back 186, I've got to go up. I've got to go up 18.6 gallons because going backwards, my gallons would increase. If I rewind my distance, then I should gain my gallons of gas back. So that means I know if I undo 186 miles, I should gain 18.6 gallons back. So 15 add 18.6 back would put me at, well, what would that be? 33.6. So that means I would have to go up 18.6 gallons, and I would be at 33.6, completing my equation, letting me know that my gallons of gas initially was 33.6, but decreased by 0.1 gallons times the number of miles that I drove. And there's my function. And so now I can figure out, I should be able to verify that, for example, if I put into this equation 33.6 minus 0.1 times 320, that I should have roughly 1 gallon left. But notice that it's a little bit off, and that's really just because we rounded to negative 0.1 instead of negative 0.1044776. So that's kind of the idea that we use whenever we're trying to model in situations where we don't know the initial value. This is a good way to think in terms of that table, and it's really important to remember that if we're assuming a constant rate of change, it's proportional. If you double the change in the input, then you've got to double the change in the output. If you half the change in the input, you've got to half the change in the output. So, i.e., a half mile, that's half of the 1 mile figure, we would lose only a half of the amount of gallons we would lose for 1 mile.